So the goal was to figure out how to move your ball 100 pixels per second to the bottom right, like towards down and to the right. And it is incorrect to move the ball 100 pixels to the right and down. So if I have my little engine here, let's use this guy here. And I'm going to use a little ball. So you guys are able to move a ball in one direction. So if you do shape.move 100, and then you multiply that by dt.as seconds, that'll give you 100 pixels moving to the right. Okay, so this will make it so that the ball moves 100 pixels to the right per second. Cool. You can also make it move 100 pixels down per second. But you know that if you're moving something to the right at 100 pixels per second and down at 100 pixels per second, it's actually moving faster than 100 pixels per second total, right? How fast is this actually moving? When it's moving 141. How do you know that? Because I told you, yeah. But also it's Pythagorean Theorem here to figure out how fast it's actually moving. So Pythagorean Theorem says a squared plus b squared equals c squared. So a squared, which is 100 times 100, plus 100, then square root of that. The ball is actually moving 141 pixels per second. So when I wanted to move 100 pixels per second, how do I figure that out? So this web page here tells you exactly what you need. So the trick is that you need to solve for the y and the x velocity. And it just so happens that these triangles put little labels next to what is y and x here. So there's a couple formulas here. Sine of theta is equal to opposite over hypotenuse. That's what this says. SOHCAHTOA is sine is equal to opposite over hypotenuse. That's why it says so. Ka is cosine of adjacent over hypotenuse. And TOA is tangent of the angle is equal to opposite over adjacent. So SOHCAHTOA is a way to remember, is a mnemonic device to remember what these formulas mean. So sine of an angle is equal to the opposite over hypotenuse. Well, what does that mean for us, though? Like we have, so if I just make a little document here. So the sine of the angle is equal to the opposite divided by the hypotenuse, right? That's what we said it is. So what do we know so far? So we know that this triangle here represents a direction that we want to go. The hypotenuse here is the speed at which we want to move in that direction. Opposite is going to be the y-axis. So let's just rename these a little bit. Hypotenuse is going to be the velocity that we want to move. This is actually equal to 100 here. Opposite here represents our y velocity. That's what we want to know. And an angle here is this theta angle right here. But in our case, we want to move exactly down and to the right, which means we want to move from in the same speed, x and y. So these two things, these two sides are going to be exactly the same, which also means the angle, like if I move straight across from left to right, that's an angle of 0. If I move straight down from top to bottom, that's an angle of 90 degrees. I'm aiming down 90 degrees. So halfway between those two, my angle is actually 45 degrees. So if I want to know what this y velocity is, how do I solve for this equation here? How do I take this equation and solve for y velocity? Well, algebra tells us that if I multiply both sides by 100, so 100 times sine of 45 is equal to y velocity divided by 100. So it's equal to 100 times 100. What happens when 100? This is equal to the same thing as, I know I'm doing an algebra lesson here, is equal to this divided by 100. It's the same thing, right? This is equal to 1. Cancels out. Then the answer is my y velocity is equal to 100 times the sine of this angle. What is the sine of 45 degrees? At 45 degrees, take the sine of that. That is 0.707, and I multiply this by 100. This is my y velocity, 70.71. Which means I could just stick that in here, like so. Maybe not so many. And my that's my x velocity and my y velocity, because I want to move exactly diagonally 45 degrees. So that's great and all. What does this actually mean? How do we get this number? Like, I used the calculator to do this, but you can actually solve this without using a calculator at all. You can do this in C++. So if I have an angle that I want to move, which happens to be 45 degrees, I can solve for this. I can have my x velocity and my y velocity be solved by C++. So if we go back to the web page here, x is equal to this formula, cosine of adjacent times hypotenuse. Is equal to cosine of an angle, whatever it is, times the hypotenuse, hypotenuse. And the hypotenuse here is 100. That's our speed. This is all it takes to get our x velocity. Our angle here, though, if you use cosine in C++, this is expecting it in radians. So if I rename this thing to be angle in degrees, how do I get angle in... Do you guys remember what radians are? Here. So a circle normally has degrees, right? Here. None of these images are very helpful. How about... That's what I want, but I want more than that. How do I draw this? Here we go. This is a good one. Give me a good image. All right. So 0 degrees is the same thing as 360. Remember, that's the same 360 degrees in a circle. This is going around this way, which is actually not the direction I want to go. I want to flip this thing. I might just have to draw this. You guys are gonna love this. There's never an image available when you need it. You get to see my amazing Photoshop skills again. This is a treat. It's like my favorite part. Okay, 640. All right, so here's our circle. Right? There's our circle. Okay. So for us, it starts off at 0 degrees. Right? And then, all right, Photoshop. So this is going to be 90 degrees, right? It's going to be 180. Okay. And it's going to be 270, right? So this is the direction that our degrees go. 0 degrees is going to be straight to the right. 90 degrees is going to be straight to the bottom. So remember, we said 45 degrees is going to be this way, right? Halfway between those. So radians is a way to represent this circle in terms of pi. So you have 0 pi here. A circle in radians, a full circle is equal to 2 pi, which means here, instead of 180 degrees, this is pi. Okay, so this is 0, this is pi. So going from 0 all the way to pi. If I count one more time, this is going to be equal to 2 pi, 0 or 2 pi. So why is this important? It's because you need this information to convert from one to another. You use this conversion a lot. Let me just increase this by... All right, so what I'm going to do is, how do you convert from degrees into radians? Knowing that you want, I'm just going to use, okay. Right, so I know that I want to get 45 degrees, right? 45 degrees. Can you guys see that? How many, that's 45 degrees out of 360. That's what I currently know. That is equivalent to some number over 2 pi. Who knows what this is?
0.25 pi.
Why is it 2 pi? Well, there's 45 degrees out of 360. There's some number out of 2 pi.
I'm saying it's 0.25 pi.
0.25 pi.
Yeah,
That's what the answer is.
I think so.
Well, how do you solve this
No,
equation?
number over it, wouldn't it be 0.25?
How do you know that?
Because 45 is like a quarter.
Oh yeah. Oh okay. Yeah. Oh, you're already like solving. I'm just saying for any arbitrary angle. Let's just say this isn't 45. Let's say this is 46. Like how would you solve that, right? Yeah, you're right. You can estimate it, which is nice. So how do you solve this problem right here?
No idea.
It's another algebra. It's all algebra. I think it's good to know. So I have this. So how do you solve for this? If this is our x and our unknown,
60x
so you multiply both sides by 2 pi times 2 pi over 360 is equal to our answer x. So what is this answer right here? 45 times 2 pi over 360, if I put that in the calculator, 45 times 2 times 3.1415 divided by 360, 0.78. That's great and all, but I'm going to stick this formula right here. This 2 pi over 360 is what I actually want. Remember, the reason why we're doing this is because it expects an angle in radians. And the angle in radians is equal to the angle in degrees times 2 times pi divided by 360. That is the formula you need. Plug this in here, and bam, there's your x. And you can stick this in here for your y as well. Now your x velocity is this, and your y velocity is this. It should look exactly the same. But now, let's say I want to move my ball 10 degrees down. So I want to move my ball 10 degrees this way, so slightly down to the right. All I have to do is change this right here. Does that look like 10 degrees to you? If I drew a triangle here, that would be 10 degrees. In fact, I think if I do this, it looks like 10 degrees to me. What about a 70-degree turn, right? So that's a 10-degree triangle, right? A much more steeper version. Same result. This is how you get aiming in games. Like, if you want something to shoot at a specific direction, let's say I want him to shoot slightly down and to the right, this is the angle you pass it. In fact, let's just say I set him in the middle of the screen here, and I want to move to the left. How do I have him move to the left? What's the degrees I would pass in here? If you go back to this chart here, what is to the left here?
170.
170? How about 180? See how he's moving to the left? That's me shooting a bullet to the left. What if I want to aim slightly up and to the left? I'm going to shoot a bullet up and to the left. This formula works for anything, right? You can even have it change over time. So if I wanted to, I could just make this thing change 90 degrees times. I'm going to have it rotate. I just drew a circle. You can draw bigger circles. This is also how you draw a circle believe it or not. It's actually, no, it actually is. It's like you write a loop that picks points along a circle, and then you go through a loop and you just increase the degrees every time. And this formula here figures out how the x and y break down into there. All right. Okay, so that's how you do the lab for making the ball move at 100 pixels per second. So I just want to kind of do this bouncing one for you guys for this lab because we're running out of time, and then you guys can do the acceleration part. And then I'm going to show you how you can get the ball to bounce. I'm going to have you guys do the bouncing on all four sides yourself. I'll do these four, and then I'll show you how that actually works. So let's put this back. Let's make this ball, this white ball bounce, because this is actually part of a lecture as well. So my ball is currently moving down, up and to the left, right?
It's drawing a circle.
Let's draw a circle. Poor little guy, he's orbiting. I don't want him to orbit. I want him to move, I don't know, let's just have him move like negative 40. Negative degrees also works because it goes behind. So I'm going to have him go up there and bounce, okay? So he's going to bounce off that top wall there. So what is his position right now? Like here. He has a position of y that's like, y starts here at 0 and goes down to 512 near the bottom. And when he goes above the edge of the screen, what are his positions? He's going negative. So how do I know what that is? Let me just print out what that is here. If I just do cout, ball position is, ball y position is. How do I get the y position of a ball of this shape? Yeah, so there's actually a this little lab. I put a link here. The first part of this tutorial talks about how to get the position of something. So you do this. So you take this little guy right here. I'm going to copy him. Do this. Change this from entity to shape. So position dot y will tell us where that ball is in y. So I'm going to keep this up on the left side here while the ball is moving so you can watch what the shape position is. So look at where that y position is, going down to 0 and then going negative. So if I want this thing to bounce, I want to flip the velocity. When should I flip the velocity of this? When it gets to 0, right? Or negative, right? So how do I flip the velocity? Well, if you had a key, right, if that type is equal to SF keyboard, key pressed, and I'm just going to have spacebar reverse it. I can set up my y velocity here. I'm just going to move all this stuff above. I already have a y velocity. Hopefully you guys all have that too. If I just multiply this by -1, when I hit the spacebar, it'll actually flip the y velocity of my shape. All right, so it reverses it. So if I do this right when it hits 0, right, it's like the ball bouncing. If I let it go, if I look at the position, and I basically manually do this, right, that looks like it bounced, right? So how do I get this behavior when the position is negative or 0?
Get position.
Well here, so what do I have to do to make it? How do I flip this velocity when the position is less than 0?
Multiply velocity by -1.
Yeah, if the position is less than 0
Yeah.
or equal to 0, then take my y velocity and multiply by -1. Or position.y, because you won't care about the y position here. This is the very first collision detection. This is the very first piece of colliding. You're colliding with one piece. I'm not touching anything, and the ball's bouncing, right?
I've been trying to do that for so long, it's still not.
And you do the same for x, right?
Bam. Okay, so let me output the x position as well. I'm just going to do x comma y. So I'm going to print out the x and y position together on the left here. Okay. So it hits 0, bounces. Cool. What if I make this thing move up and to the left? Should still work, right? doing some funky things before it bounces. So this is one of the reasons why I wanted to talk about it, because you'll see this often in a game like Pong where it gets stuck. And see, it didn't get stuck that time. Oh, it's gonna. My angle aiming is not quite correct. But let's make it bounce off the left wall, and I'll show you why it's getting stuck in the top. So it's going to bounce off the top, and then I want it to bounce off these sides as well. Look at the x position here. It's going to 0 as well, right? So if I set this up correctly, I can make it so that it'll bounce off the left wall as well. So how do we know when it bounces off the left wall? What is the x position going to be when it hits the left wall? Got stuck. But look at the x position. Goes to 0 and then negative, right? So same idea. If I set up the x position here, why don't I set up another condition that says if the x position is less than or equal to 0, I'll flip the x velocity, all right? So now we set it up so it should be able to bounce off the top and the left side. It's getting stuck on the left side as well. So I want to talk about why that's happening. So why does the ball end up almost like sticking to the top and to the sides? So this is a very classic common bug that happens, and it all has to do with how the ball is moving ever so slightly outside of the edge of the screen, and then the next time through is actually still outside the edge of the screen. So what actually is happening here, and if I were able to slow it down, see right there, the ball is outside the left edge of the screen right now. So if I tell it to start moving to the right, the next time through, it's technically still outside the edge of the screen. In fact, if I let go right now, the ball's lost. It's actually gone outside of the screen completely. Because the problem is that it's not actually enough to just flip the velocity of the ball. So watch what happens. I'm going to actually try to catch it so that it actually breaks. So I'm going to try to have it go off the top edge of the screen. So here. So it actually vanished. Look at the Y position right here. You guys see what the Y position is doing? It's like going down and then going up again. Because it's constantly flipping the side that it's on. Watch. Let me draw this out. I'm actually going to freeze it right here. I'm going to stop the ball from moving when it goes off the top edge of the screen. So watch this ball. It's going to stop. Look exactly where the ball is. Okay, so it got stuck. I'm actually going to freeze it from going off the left edge of the screen too. I'm doing funny things. You guys can't really tell, but there's a little piece of that ball that's actually outside of the screen. It's actually, and I'm gonna show you why this makes sense, because I'm gonna speed up the ball quite a bit when this happens. I'm just gonna lock the ball in place. So that ball has a shape to it. It actually has a radius associated with it. But there's a little piece off the top edge of the screen. That ball is currently at negative 0.391. What's actually happening is that the ball is just ever so slightly above the edge of the screen right here. And we're telling it to flip and move this way, right? The next time through, it's like, okay, I'm going to try to move the ball. It tries to move the ball this way, but it doesn't move it enough, which means it stays stuck up on top there because it doesn't move it outside the edge of the screen. And when that happens, the ball is still outside the edge of the screen, which means it flips the velocity again. Let me show you what happens when I speed this thing up by a lot. So if I take this velocity here and I make it like, I don't know, 1,000. You see where that ball is? See how much is outside of the screen now? Can you guys see that? See how much of the ball is actually cut off here? That's because that's how much the ball moved in a single frame. The ball moved this much off the top edge of the screen, which means when you tell it to bounce, it's only going to be able to move somewhere. It might only be able to move like half of this. It might only be able to move a little bit down off the edge of the screen, which means it gets stuck up there. This is a problem because once your ball starts moving super fast, I'm going to make my ball move 10,000. What actually will happen is that ball will actually leave the game window. Actually escapes outside the game window. There's no ball up there. I didn't catch it. I didn't get stuck, right?
That's too small.
What's that?
The edge is too small.
The edge is too small. In a way, though, it kind of is, because it's actually saying that as soon as you figure out that it's negative, it stops it, right? It freezes it as soon as it figures out it's off the top edge of the screen. But look at where it ended up, negative 152. It moved this much in a single frame. So how do we fix this? The fix is that you're not going to be able to catch exactly when it goes off the edge of the screen, but you can correct it so that it doesn't go past the edge of the screen. So if I set this up so that not only do I detect a collision with y, but I take my shape and I set the position of it equal to inside the screen, that'll work. So I have my current position here of where the ball is. I'm going to keep it where it is on x, which means I'm going to pass in the current position of x. But for y, I'm just going to set it to 0. That's all I'm going to do. I'm going to set it to 0 here. Now watch what happens when I run this. You'll see the ball pop. 0?
You also still have to go by 10,000.
Oh, yeah, it's actually still moving by 10,000. Let's see, shape position. Ball position is 0. Draw. Let's do this. Let's actually see it moving here. Oh, I wanted to do 1,000, sorry, not 10,000, not 100. Then we'll crank it up. Can you guys tell that it's not going outside the bounds of that anymore?
Yeah.
It's stuck up there.
It was out the bounds, but it just got put back in.
It got put back in. It got pulled in. The reason why this thing doesn't work is because it actually is moving so far fast to the left that it's actually getting stuck all the way over here. It actually exited up here, got this far, and then got pulled back down again. So it popped. But that's kind of what we have to do. So this is the behavior that I'm going to do on both cases. So I'm going to just put my behavior back to flip the y velocity. I'll put this behavior back to flip the x velocity. And here, I'm going to set my position equal to 0. So now, I'm bringing it back in. So it'll bounce off the top and the left no matter how fast it's moving. Did I flip the y velocity? Oh, no. Sorry, that's what I want to do. Cool. So it bounced off the top and left. So, how do we make it bounce off the bottom of the wall? What is the position of the ball? I'm going to have it move down now, right? And move it slower. Look at the position of the ball here. That might have been too fast. Let me move it up so it's actually starting at the near the top. Watch the position, the y position of the ball while it's moving. It's 3, 4, 5, 12, right? So when the ball hit 512, that's when it's off the bottom edge of the screen. So we can set up another if condition that says if the y position is greater than or equal to 512, also reverse the velocity, and set the position equal to 512 here.
That's only if you're starting in the middle of the screen, right?
This doesn't matter where you're starting, actually. So watch what happens. Going to go off the bottom and then bounce.
Why does it go off the bottom?
Yeah, why does it go off the bottom?
That's
That's
what
actually in the lab.
That's what mine does too.
Yeah. Why does this ball disappear off the bottom edge of the screen before coming back up? Well, let me make this ball giant here. I'm going to make this ball 150 pixels.
You have to set the origin.
It's like the sun setting and rising.
The origin's at the top of the circle.
Yeah, so one thing is that the origin is at the top of the circle. Remember, everything is at the top left corner of the circle.
150 from 512.
Well, we can also just reset the origin.
Yeah.
Okay, so let's try that. So I do shape.setOrigin. I know it's 150 pixels, so I'm going to do 150 as the origin, 150x and 150y. So now it'll be the exact middle of our shape. So watch where it actually collides now. Boop. Right in the middle now. But it still kind of sinks down a little bit. It's like dunking an Oreo or something into the bottom of the screen. Why is that still happening? Well, this shape has a radius, right? We're checking to see if the middle of the shape is off the edge of the screen. Right here, or right here. Now it's almost off the edge of the screen. It's the middle of the screen, right? But we actually need to account for the top of the bottom edge of the circle. So we actually need to collide with it when it's right. I'll stop it right when it's here. Oop, almost. You guys get the idea, right? I'm going to stop it here. Bam. Yeah. I want it to account for the radius, so I actually need to account for the radius here. I'm checking to see if the middle of the circle, this is the middle of the circle, is greater than 512. I actually need to account for the middle of the circle, including the radius. So if I do shape.getRadius plus this will account for the radius of the circle properly. So now it'll say that, hey, if my position plus my radius is greater than this, then bounce. We're also teleporting him to be 512. This needs to account for that too. Well, let me just do this first without doing this, and I'll show you what actually happens. So watch what happens with the ball now. Bounce. The very bottom of the edge gets hit. How do we get this in properly? This 512 needs to subtract the radius, because we're teleporting it above the bottom edge of the window. If I don't have this in, watch what happens to teleporting it when it goes off the bottom edge. It actually snaps to the bottom like that and it gets stuck there, because that's where we're teleporting it to. We're teleporting the middle of it to be at 512. So we actually need to do this. All right. So let's make it bounce on all four sides now. So we're going to do a 45 degree, negative 40. 270, 200, maybe 180, 225. So we're going to have it move to the top left. The top is not accounting for it either.
Yeah, you have to do supposition.
And neither is the left side, right? Only the bottom is accounting for it. So everywhere where we're doing this, we need to account for the radius. So when we're bouncing off the top, we have to account for the radius. When we're teleporting here, we have to account for the radius. Same thing here as well. All these things need to count for the radius. A giant ball. Anyone see that episode of The Office where they're watching the DVD logo try to get into the corner? You ever see those like screensavers that bouncing? It's off the edge, the right edge of the screen, because we don't have a collision there. And this works for any radius. Like I'm going to shrink this ball down. I'm going to shrink it down to like 25 and make it move much faster.
Change the origin to.
Oh yeah, good call. So one thing about changing the origin here, I don't actually need to type in 150 here. I can do shape.getRadius. And no matter what radius I have, it'll always be correct. And I'll give you guys this lab too so you guys can have it. Here's my ball. Okay. So I'm going to give you guys this lab right now because I want you to make it bounce off the right side properly. Okay? So here, I'll put this up on Zool. So take this in the time that we have and add behavior to support. It's engine.lab CPP. You can either open this up and copy it or copy the whole thing to your local folder and make it bounce off the right side of the screen. And that'll be that's the last piece of lab for lab number 1.
Lab one?
Yeah. The homework actually doesn't need lab 2 to do it, so. Yeah, so what I want you to do is make it bounce off the right side of the screen properly, now that you know what it's doing.
It's weird is when I add the shape to origin, it like sets it offside that it completely blocks the screen.
That's right, because that's where you're positioning it. Your setting
okay.
position at 0, so you want the position at whatever the radius is.
Can I just do that?
Yeah. You have a plus. That's right.
Oh.
I got a question for you.
Yeah.
Just one.
This is how Pong works, by the way.
Alright, so I have to sit there and actually have the radius in order for it to get this to work, right? That sucks.
I set up 3 if statements. You need to write the 4th if statement.
I mean, yeah, I pretty much got it on mine, but I just gotta change for the name.
Yeah. You can just copy that file, like copy the contents of it, and paste it. If you allow. And write the last if statement to make it bounce off the right side.
What did you name that one?
What's that?
What did you name that one?
It's in the root SDVA203 folder. It's called engine-lab. Up 2 levels.
Not that one.
Yeah, go up 2 folders.